Study with Steph, cause she's the best. She's gonna help you get your CTS, yeah.
Ain't nothing can keep me down.
Stephanie.
Hi, everyone. Before we start this episode of Study with Steph, I wanted to make a brief announcement. We have been putting our heads together over here at how to do a good giveaway for Study with Steph for all of you who have hung on this far. And we are giving away 50 Study with Steph branded t-shirts, which is really exciting. So here is how you get in on that if you are interested. There will be a form linked in the description if you are watching this or listening to this on ravepubs.com. And all I need you to do is click on the form, fill out that information, and I will let you know if you have a shirt coming your way. So thank you so much for listening. Please keep doing it. Please study with me so that I have some more motivation to keep doing this. And I hope to see you all at InfoComm. So without further ado, here is the episode on control systems, and I will talk to you guys later. Bye. Hi, everybody. Welcome to the latest episode of Study with Steph. In each episode, I am studying a chapter of the CTS hand guide because here's a surprise, I am trying to get my CTS. And here's another surprise, it's very hard. So I invite a subject matter expert with me for every episode. And today's episode, I have with me Steve Greenblatt. He is the president and founder of Control Concepts. And it is a company that specializes in control systems, which makes the control systems portion of the test the perfect test or perfect portion to have him on and be a guest. So thank you so much for joining me today.
I'm glad to be here. I hope that I'll be able to help. And this is certainly an area that I can speak on. And I wish that it was a bigger part of the test, actually.
Yeah. I when I got to this chapter, I was like, I don't think I know anyone off the top of my head who hasn't already been a guest, because Hope Roth was my last guest and she knows a lot about this as well. So I put out a call to LinkedIn, and one of my LinkedIn buddies was like, he'd be great, have him. So yeah, I figured we could just jump right in. So at the most basic level, if I am just asking, when we say a control system, what do we mean? And its most basic form, what do those words mean?
Like many things in AV and in technology, it has different meanings to different people, and it's different the way our industry speaks about it and the way other industries may speak about a control system is actually something that's used in manufacturing as well. And so there's many different control system ideas, but from an AV perspective, the way I look at it, and maybe I'm glorifying it because it's so near and dear to me, but it's the brains of an integrated AV system. So you have all of your different components, you have your displays, and you have your inputs, and you have your audio and your speakers, and the control system is what sits in the middle of it and talks to everything. And it's actually the part that most people really appreciate when it comes to the hardware, because they interact with it. The control system not only involves some type of a CPU, which is a computer that holds programming and talks different ways to different pieces of equipment, but it also supports the user interface, which is the part that most people really appreciate. And that's really where the user experience comes in. And that's a big part of what we do these days.
Gotcha. So when we talk about a control system, what can it do? It can do a lot of different things, and it can be for a simple solution or it can be for a really complicated solution. So how do we classify all the things that are possible that it can do?
That answer I would say is in broadest form, it can do just about anything, but it needs to be designed that way, and it depends on the equipment that you're working with. The programming is what actually is the customized part of it, and what makes it do what it needs to do. And different manufacturers support different functionality and different operations within their programmed, and sometimes you'll hear configured solution. But the whole idea is that if a user has a need, you use a control system to satisfy it, and based on a combination of the equipment that you select, the design of your system, and then the programming that supports it, that is how the control system serves a solution and actually addresses what a user is looking for. But in general, it can do one thing. It can do a combination of things. And a lot of times the whole idea of it is to provide simplicity and specificity so that you're not giving the user too many things to choose from. You're just giving them what they need.
Got you. So how the study guide kind of describes it is thinking of a function versus a program. And I just kind of need some help, like understanding the difference between the two. How it kind of explains it is like a function is like one action, but then a program is kind of thought of like as a chain of commands and a chain of functions in a way. Is that like the best way to think about that? Or is there kind of an easier way to get your mind around it?
What you just described can be said in many different terms. One way
Yeah.
is that you could call it you're providing direct functionality. So I press a button and something happens, and that's one thing that happens. So if I press a button on the wall, it turns my lights on. And every time you press it, it's going to turn the lights on. But you may have another button that you program to do a sequence of things, and that could be that you turn the lights on and you are going to start a presentation. You may adjust your volume level. You may turn on a display and maybe display your laptop on a screen. So that would be that sequence of events. Sometimes it's called a macro. Sometimes it could also be looked at as that's also automation. So it's direct functionality is one button to one function, whereas the sequence or the program, as you mentioned it, is one button to many steps.
Okay. That makes sense to me. So now let's talk about components and interfaces. So the primary component, they say it's always called the central processing unit. And that I've heard of, that I know just by like being a person who's lived in a world that like has a lot of technology in it. But when we think about it in the context of AV, like when we think of a CPU, that's just like the main controlling system that talks to all the rest. Or is that not the way to think about it?
Yes. So,
okay.
So almost every system is a collection of boxes, and you know the AV industry gets
the classic little black
bit.
boxes.
Yes. So the CPU is the control system box, and that's where all of the devices get wired to.
Okay.
So it houses the program. So that's where when you and it also so it speaks to maybe a touch panel or a keypad, which would be the user interface side, and then it also talks to the third-party devices. So that could be a screen or a projector or an audio DSP or a video conferencing system. So the CPUs, and I know that part of what we'll also discuss is different control methods. That actually is where the connections go from the device to the CPU to satisfy those control needs.
Okay, cool. And when it comes to controlling multiple devices, like across like a long distance or something, there are like different configurations that make this happen. So there's like the book talks about like distributed intelligence and distributed processing and edge processing. Can you help me kind of understand the difference between those three?
the main CPU has is what talks to the devices, but the devices themselves may have programs in them too. So something like an audio DSP that you would use to control volume in a room or to do audio conferencing, let's say, that too has its own programming in it. So the control CPU needs to speak to that audio DSP in the manner that they are both set up for. So they both have a certain amount of intelligence in them, and they're both set up in a custom way. And then they're tied together through whatever language is established, and
Okay.
certain what they call programming hooks. It's the different parameters that get adjusted. I hope if that helps.
Yeah, for sure. So then when it comes to control signals, this has to do with the way they communicate the sequence of actions that they each need to do, correct?
Yes, and they're determined by the type, the device, what that third party device supports. So
Okay.
like a DVD player, many times that would be an IR control device if it has a remote control that we're all used to seeing. But it also might have other methods like a network connection and Ethernet control, or what's an RS-232, which is a 9-pin connector. And the different control methods are based on what the device is capable of supporting, but it also has to do with the pros and cons of using one method versus another.
Okay. So are there ways that like do they go to in different directions, or is it always like a bi-directional type of communication?
Well, so an IR device is always one way.
Okay.
And so and a good way of knowing that is that when you turn when you press a button on your remote control, if you are at home in front of your TV, and you don't get any response back other than
Right.
seeing the TV change. But if you're going to go into a more sophisticated control method, those have they're what's called feedback. So you send a command, and the device will respond to it.
Okay, that makes more sense.
And it does depend, without getting too technical or in the weeds, it depends on what that device does.
Okay.
So each one has its own what's called API, which is application programming interface, and it's the commands that it supports, and the programmer would need to interpret that and know how to put that in their program.
So going back to like the types of control systems, like what would you say the main ones are, or like the most common, or the ones that like would maybe be most likely to show up on the exam?
From a manufacturer, like a brand standpoint, or a usage standpoint?
Usage, probably.
So you would have controls. Most integrated systems where you're using a collection of equipment, and somehow you need to be able to make it easy to use. So one way of doing it is you press all the buttons manually, and but we know that presents complexity and also opportunities for errors.
If you don't remember the right sequence of buttons, yeah.
And or you're just not technically capable, or it's just because it's a burden. So then by putting in a control system, you simplify that. It's similar also to if you have a bunch of remotes on your coffee table and you want to condense that, so you just have one remote.
Yeah.
That also is another form of a control system. You would see them very commonly in a classroom, at a lectern. You would see them at a conference room or boardroom table. You would also see them in different smart homes as well. So what is also the case too is that we're starting to see some that are touchless. So
Mhm.
you don't necessarily know that it has a control system there, but you might walk into a room and plug in a laptop and then things happen for you. So that's another version or another application where you would see a control system.
Got you. So when you talk to me a little bit about IR control, and you said that, like, that's one of the most basic forms, that's a remote control controlling a TV, because it's like very basic. It's a one-way communication. Contact closure control, like its definition looked very similar to me, where it's either like on off. Like how do I, like, what's a useful way for me to not get that confused with IR?
Okay. Well, IR is a over the air method. So
Mhm.
you use your remote, and if you're not pointing your remote at the right place, it may not work. Whereas
Yeah.
a contact closure is a hardwired connection, and even without a remote, without a control system, if you take the
Mhm.
two wires and put them together, you're making that contact as defined by contact closure, and you should see something happen. So sometimes that might be lowering a screen, sometimes that might be lowering a lift,
Okay.
sometimes
It's manual.
it's a lot more mechanical, I think is
Okay,
a good
that's the
way to
word I was
look at
looking
it.
for. Yeah.
Yes, yeah.
Okay.
and
Awesome.
and it also simulates a switch. So you turn your lights on, it's one way, and you turn your lights off, it's another way.
There are two options.
Yeah, it could, yes.
And with IR, there's more options than just on or off. There's changing the input, doing this, right? Okay.
And the way that works is that each manufacturer has codes for the different functions that they use, and you capture those codes and put them into your program.
Okay. Got you. And then with variable voltage control, what is that?
So that's not something, honestly, that you see very often. Quite,
Okay.
to be frank, what you might see that for is for a temperature sensor. So if you have if you're trying to get a reading of a temperature in a room, you need to. It wouldn't be just an on or an off. It would be a certain amount, and that
Okay.
amount would correspond to a voltage that you would bring into your system.
Okay. Cool. And when it comes to serial digital control, you brought that up earlier when you were talking about an RS-232, but in the book it talks about knowing the difference between RS-232, RS-422, RS-485, and this is just to me like a jumble of numbers. Do you have any advice for helping me keep those straight?
Yes, definitely. And you're not alone. I mean, I've been doing this for a long time, but when I first started, I had no idea what any of this meant, quite honestly. And I went to school for engineering, so I'm just telling you that it's just terminology, honestly. That in the
Okay.
AV industry, we don't have to know all of the electrical properties of it, whereas maybe other industries do. But there are different ways to communicate, and they have to do with the wiring and the voltages used, as well as the distance that can be run. So RS-232, the main thing to understand is that it's 50 feet or less, and it's point to point. So
Okay.
you have a cable that usually has two connectors, one on each side. One goes to the control system, the other goes to the device, and at most it goes 50 feet. RS-422 allows you to go considerably longer. If I'm going to tell you off the top of my head, it's probably a couple hundred feet.
Let me look. This says 1,200 meters.
Oh, so it's quite a distance. So probably like 3,600 feet or something
Yeah,
in that
yeah,
nature. Yeah,
3,600, 4,000. Yeah,
yeah.
it's quite
So
it's quite more than 50.
quite more. So, but you can't although even though a control system may support RS-422, the device itself has to as well.
Okay.
So we don't necessarily have say over which method you use. However, you may pick equipment that if you have to go further needs to
Hmm.
support RS-422.
Okay. Is it kind of like when you buy a 4K TV, but if you don't have a 4K supported HDMI and a 4K supported Apple TV, and then the content in 4K TV, you're not going to have 4K. It's kind of like similar to where all the pieces have to match.
That's correct. That's
Okay.
correct. The wiring has to match, and the two ends have to support it.
Okay.
And
And unless
RS-45
you're
is going one
yeah.
step further. And that also supports multipoint, so you can chain devices together.
Okay. So, and then unless you're the designer, you don't really get to pick what gets used on a project. You kind of more show up and you're like, hey, this is what's being used. Make sure that everything you're coming with supports this because it's already designed. This is how it is. Just like make sure that everything you're bringing supports the design.
Yes, we as a programmer will help to think through the system. We'll look at a design. We may make some comments or questions or suggestions, but yes, you're correct. There is only a certain amount of wiggle room that we'll have to, even though people think you could fix everything in programming, there still are hardware limitations that can't always be overcome.
Okay. And then RS-485, what is this? What is that one?
So that also is a longer distance, and the other part about that is that allows you to connect devices together. So one device would connect to the next device. They would be daisy chained.
Okay.
It gives you that opportunity to do that, and the devices are addressed. So it provides the ability to wire a lot easier, so you don't have to wire everything back to the CPU.
Okay,
But
whereas
again,
with 422, you do have to wire everything back to the CPU. Okay.
that's correct. That's correct. And the difference, they're different wiring, and they also have to be supported.
Okay. So in an install, like what would be an instance where RS-485 would be used? Like what kind of system would that look like?
Well, one of the things that's funny is that the control systems themselves, they support RS-485 back in the day to connect their devices together. So the touch panel would connect back to the CPU with RS-45 because of the flexibility of it. But I don't know if I could think of a device off the top of my head that would be RS-45. In particular, it would more of be something that, so I think a camera may be a good example of, because you may have a collection of cameras in a system, and they would daisy chain to each other so that you can control the different ones all from one connection back to the CPU.
Okay, that makes sense. And then the last one it talks about is USB. And I know what that is in terms of like it being a connection, but I did not think of it in terms of it being a form of digital control. So I don't know if it's thinking of it in a new context or what.
So the ability to control something over USB is not something that's normally programmed, but it is included within the system. So I can't think of a way that we have controlled something per se over USB, but it's definitely gets switched, or it's part of talking to a processor. So you would connect your laptop to the CPU to program it with a USB cable.
Because the USB is pretty distance limited, right? Like you can't put that over 4,000 feet like you could.
Not even 50 that easily.
Yeah, I think it's like it's like 16 feet or something.
Yeah.
But it talks about that there are USB to Ethernet adapter systems that allow it to be like extended to the internet. And that's like why it's included in the chapter.
Yeah, I don't know how that would figure into control. It's kind of interesting. It's certainly a part of talking between computers, but not necessarily something where you would talk to a device over USB. Okay. That at least that I've encountered.
Okay, that's all I need to know. The other ones are much more of a common terminology. Okay.
Yes.
When it comes to the control systems context. So when it comes to radio frequency control, this is instead of devices communicating via like a cable or something, this is communicating over radio waves.
Yes, and many times that is used when you have a wireless touch panel,
Okay.
and that so they would use an RF signal, and then from there it went to Wi-Fi, where you would connect your touch panel back to the CPU so you can be more portable with it.
Mm-hmm. And then Bluetooth is like the one that's like very common. It talks about that being under RF control. And then Zigbee as well. I don't know much about Zigbee as like a form of wireless communication. I know that there's a Zigbee Alliance.
Yes.
But this is just something that uses a mesh network, right?
I honestly had to look that up because I all I know of it as the way you would have a touch panel talk to a CPU, but it does it is a low power, so it does a small distance, and it's I think that one of the things that's good about it is that it probably has more reliability because it's low powered and close.
Okay. What's most common that we're going to see in like
Wi-Fi.
one of these devices is Wi-Fi. Okay,
yeah.
That makes sense.
Yeah.
That's like the main one. Because that's what we have in our conference room. So I was like assuming that that's what most people have in their conference rooms too.
Yeah, these others are I think very purpose driven. So when you can't have Wi-Fi, then you would put in Zigbee or Bluetooth because of one reason or another. Maybe it's a more secure environment, or there's interference. So it just presents different options.
Okay, for when you're in kind of a tight spot, and if Wi-Fi were your only option and that didn't work, you're permitted more options.
And if you think about it, a lot of people are using these days iPads to control their system, and those work on Wi-Fi very commonly. So that's one of the reasons to remember. I think that Wi-Fi is the most prevalent.
Okay. And when it comes to like networked control systems, this is communicating over Ethernet.
Yes. So this is what you're going to see a lot more often, and is really what modern control systems are doing. And kind of going back to your question before about being able to cover more of a distance and having more devices across the internet or across an enterprise. Nowadays devices have become IT appliances. So everything has an Ethernet connection, and those connections may be used for control, or they may be used for audio or video as well.
Okay. So this is kind of an example of like the AV-IT convergence that we talk a lot about in our industry.
Absolutely.
the argument that is AV-IT, or are they two completely separate things? This is something where they kind of come together.
Absolutely. And the thing to know is that when we're on a corporate network or an enterprise network, we have to make sure that we're playing by the rules that somebody else sets. We can't necessarily set them, and we have to be responsible for security, and we have to be responsible for making sure that we're disclosing what we're putting on somebody else's network.
Okay, got you. So as a person who has a CTS, and I'm a person who's trying to get a CTS, what are some general pieces of advice that you have for me while I'm studying to take this test? Any study methods, study tips, anything you got, I'll take them.
It's been a long time. Unfortunately for me, I took it, I think 15, 16 years ago, which I'm very proud of, but I think it was a little bit different then. What I've heard from a lot of people is that you have to understand to know what answers that they're expecting of you. So there are doing practice tests and being able to see as many questions as you can, and understanding how the questions, how the answers are worded is very important. And even in us speaking about this prior to recording, we talked about a couple of questions, and one of them I had to really sit down and look at to try to understand what was the answer that they were looking for.
Yeah. Which question was that again? Did we look at together?
That was the function versus the program, and
okay. Which of the
I had to
following
read through
is
it a few
program?
times.
Yeah. So the question in the study guide, for those of you reading, we're in chapter 8. At the end of the chapter where they have some practice questions for you, we're on question 3, which was which of the following is more likely to be a function than a program? The options are starting a video conference, playing a video, dimming the lights, and starting a media player and setting volume levels. And it says that D is the answer. Setting volume levels is more likely to be a function than a program.
And that was because it was very direct. So all the other ones required more things. So starting a video conference is vague. So what does that mean?
It means you have to turn the computer on. It means that you have to set up the audio. It means that you have to make sure your mics are working. It means you have to make sure it's playing out the speaker. Okay. So
and
because
the third
you have
one, sorry, it sounded like it was going to be the answer, but then they said dimming the lights and, so right away you knew that was a multiple actions as well.
And then playing a video is the only other one that I could possibly maybe get those mixed up, because on its face it looks like, oh, you hit play, but you also would have to turn your computer system on, pull up the program in which to play the video. So then that's why that couldn't be it. Okay.
That's correct.
They're trying to get you on that one.
Absolutely.
I'm trying to think of a few other questions, like practice questions that you and I talked about that were kind of difficult. What it talks about, like things that can interfere with an IR control. And a few of the examples it gave were quality of the device, strength of the power source, shadows and darkness, bright sunshine, or fluorescent lighting. Would it be strength of the power source, do you think?
They're asking which ones can interfere. The last one, the lighting and the fluorescent. Yes.
Okay. Oh, that's right, because radio waves are on the light spectrum.
It could because it could flood the sensor, and then it won't be able to see the IR remote working because of what's actually being it's already picking up. So
okay that makes sense. But yeah, I think those were all of the questions that I had for you. Was there anything else you wanted to add, or anything you feel like I didn't really touch on in order to be prepared for it, or anything else that you had?
I just thought of one control method that we didn't touch on, but it's not always that commonly used, but it's called the digital input. And
digital input.
The reason that I bring it up is because nowadays we work with a lot more sensors than we used to. So if you commonly see a motion sensor in a room, and that gets wired to a digital input, and basically what happens is that if it detects motion, then you receive a positive signal. We would call a high signal an on, and if it's not detecting motion, then it would be a low signal or an off.
Okay.
But I think that's something that is becoming a lot more prevalent these days, where somebody walks into a room and they're looking for things to trigger, or a room is empty and they want to automatically turn it off. Okay.
Is that kind of how like people counters work, how they're setting those up in a lot of stores so that, they meet COVID regulations, that people are social distancing? Is that kind of how those work? When another person walks in, that triggers the on signal okay.
That's correct. Yes.
Okay. Awesome. I'm a type of person who needs like real world examples of everything so that I can remember what they do.
For sure.
But that's helpful.
The other thing that I'll mention, and I'm not sure if it's going to be on the test, but there's a lot of, being that there's so many more of control systems out there in the world, the manufacturer, the clients need to be able to have a method of managing them. So they use the different enterprise software to be able to have a dashboard to see what their systems are doing. They want to know if they're on or off, or somebody is something is not working. So they would call that like a remote monitoring or remote management system. And I don't know if that's going to be covered on a test, but it's certainly a big part of what is done these days in control systems.
And different manufacturers often offer different versions of these?
That's correct. Yeah.
Okay.
Yeah. And usually, and the other trick that I'll just mention, and probably again not going to be on the test, but as much as there are competitive advantages to the different control system manufacturers, they all do the same thing. They just do it in a different way. Each of them use the different control methods we discussed. Each of them have to be programmed or configured. Each of them talk to the devices in relatively the same manner. It's just what you're comfortable working with, or what your client has and they like using, or what your needs are in particular.
Okay, that makes sense. Because I mean, if you have one that's completely out of left field and different, if a integrator or someone knows how to set up and use one, then they might not know how to set up and use anything else. So it does make sense that they are all at least sort of similar.
Yes, and if you take the labels off, they're all doing the same thing.
Okay. Sounds good. Well, thank you so much for joining me. I really appreciate it. I feel that I understand this a lot better, just because, like I said, it really helps me to have someone sit down with me and like give me real world examples, because otherwise I feel like I'm just reading a lot of letters and numbers, and it's hard for me to keep them all straight as someone who is not using them every day. So I really appreciate it.
Without a doubt, I admire what you're doing, and I think it's a good example for others. And I hope that this can help you and as well as other people that are watching and listening.
Sounds good. Well, thank you so much. I really appreciate you joining me today.
Thanks for having me. Study